To wrap up this section, we're going to look at one last example here. It says the Taylor polynomial of order 2 generated by a twice differentiable function f of x at x equals a is called the quadratic approximation of f at x equals a. So we're asked to find the linearization, which is the Taylor polynomial of order 1, and also the quadratic approximation of the function f of x equals the natural log of cosine x at x equals 0. So first thing I'm going to do, just like I've done before, is I'm going to need to look at the first two derivatives of this function. So the first derivative of f we're going to use the chain rule. So when we take the derivative of a natural logarithm, we're going to have 1 over cosine x times the derivative of cosine x, which is negative sine x. So that's the same thing as negative sine x over cosine x, or negative tangent x. So that's our first derivative. Then the second derivative, the derivative of tangent is just secant squared. Since we have negative tangent, it's going to be negative secant squared x. So now we have the derivatives that we will need to find the linear and quadratic approximations here. So we'll start with the linearization. So this is the Taylor polynomial of order 1. So it's just going to have two terms. Since it's a linearization, I'll call it L of x. So it's at x equals 0. So it's going to be f of 0 plus f prime of 0 times x minus 0. So plugging in 0 to the original function. Cosine 0 is 1, but the natural log of 1 brings us back to 0. So we're going to have this equals 0. Now let's look at the first derivative. That's negative tangent of 0. Well, tangent of 0 is also 0. So here we'd have 0 times x, which is 0. So for the linearization, it's just the function L of x equals 0, just a horizontal line, specifically the x-axis. So that's not going to be the greatest approximation of this function, so let's look at the quadratic approximation. So we found the approximation that's a straight line. Now we're going to look at the one that's a parabola. So this will be the first three terms. So we're still going to have f of 0 plus f prime of 0 times x minus 0. And we already know that this is just 0. Then we're going to have the second derivative evaluated at 0 over 2 factorial times x minus 0 squared. So again, we know that the first two terms are 0. Second derivative. Secant of 0 is 1. So secant squared is also going to be 1, but we have a negative in front of it, so that's going to be a negative 1. 2 factorial is 2 times 1, or 2. X minus 0, I don't even know why I have the parentheses here. We're just going to have x squared. So our quadratic approximation is just negative 1/2 x squared.